will AI ever get the right answer right 100% of the time? Or is fundamentally the framework itself is such that it is not intended for that as an application?
So we have to step back and ask a question: what is AI? Right? So um, AI is not a single thing, right? AI is kind of a philosophy, right? So it has been applied to a wide variety of different problem solving techniques, right? If you go back to the era of expert systems, right? So there were some amazing expert systems. There was Eliza, right? There was Mycene. There were these expert systems that were actually tuned for, things like psychological counseling, or to be a clinical decision support system, and so on and so forth. And these were considered AI systems back then, right? What did they do? They were just a bunch of rules. Somebody had a very detailed conversation with a domain experts, more than one domain experts, and kind of codified their knowledge into a very, very elaborate system of rules, right? Now, these again are hard solutions, because quite often two experts would not agree on what the right answer is, right? In these domains, like in healthcare, when you that's why you take a second opinion from other doctors. So people don't always agree on what the right answer is. But the point here is, these systems used to give you the same answer all the time, right? I mean, if there was a solution on which every expert would agree on, it will give you the same answer. It will give you that answer that which the experts agree on, right?
And that trait is still, it holds true in today's AI models as well.
No, that holds true if you are building a rule based system, if you are building an expert system today, like you did back then. But what has happened today, all these successes since we have from 2010, right? I was telling you about the vision success and so on and so forth, all are based on this idea of what's called machine learning, right? So it's I mean, AI has been cursed with not having appropriate names for various things, including AI itself. But machine learning is another one of those terms, right? So the idea behind machine learning is that you capture knowledge by a very large number of examples. Okay, so this is called inductive learning or inductive inference, and the idea of inductive learning goes back to Aristotle. It's nothing new, right? So Aristotle talked about inductive learning. Basically, is it truly possible for you to learn the base fundamental principles of a domain just by looking at examples, right? So when you start talking about inductive learning, if the base of your intelligence is inductive learning, then there is always the possibility that you will not be able to answer questions about things that were not seen correctly, right? So the why inductive learning works is that you make certain assumptions about what do the examples that you see tell you about the examples you have not seen, or not the inputs that you have not seen. You make certain kinds of assumptions about continuity, and you make certain assumptions. So as long as those assumptions hold, you'll be right. When the assumptions don't hold, right? Or you do not really have enough knowledge to make those assumptions, right? You are now assuming that this complex neural network will somehow generalize to all these things that you have not seen so far. But if it doesn't hold, then you're going to go wrong, and you have actually no way of bounding how wrong you can go if these assumptions don't hold. I mean, all the analysis and other things assume that some fundamental assumptions about the data holds.
And the model itself has no way of knowing whether the assumptions have been held. In the old rule based system, it would tell you are going outside my assumptions in some sense.
I mean, you can still bound it here, but again, yeah, you can still go wrong. Yeah. Yeah. So that's a fundamental challenge here, right? So you can build AI systems. I mean, rule-based systems are still. I mean, you can still construct them, or things like, for example, Deep Blue, the chess engine, right? That beat Gary Kasparov, right? It did not use a whole lot of inductive learning. It did search. It literally did enumeration of all possible outcomes, like you're taught to think about while you're playing chess, right? You don't actually do that eventually, but you're taught, okay, oh, you should think about, hey, what are the things that your opponent can do if you make this move, now reason about this, and maybe do look at 2 or 3 steps ahead in time and then make a call, right? So those kinds of models can potentially be more deterministic, more reliable than things that generalize from. In fact, if you can do exhaustive search, right, then you can be correct all the time. But exhaustive search is more often than not not possible because of the number of possible outcomes. For example, in chess, right, every move on an average has 35 possible responses that your opponent can make on an average, not every position. So imagine that, right? If you want to look for 10 moves into the future, and it's like 35 over 10 or something. So it's just going to not work out, right? So no, 10 power 35, so it's even bigger. So that's the thing, right? So you can't do exhaustive search, so you have to start making certain assumptions about, okay, this is a useless track, I don't have to explore this, right? He's never going to make this move. And then if the guy actually goes and makes the move, then I don't know how to respond to it, right? So those kinds of things. So everywhere we make certain kind of assumptions and approximations. So that's always going to come back and bite us. But with the machine learning, we have this additional challenge of inductive biases that we don't know how we will react to when the data goes outside the assumptions that we make.